Good morning, this is your stats sensei, Mr. Spensei, and today we're going to be calculating probabilities given z-scores of a normal distribution. But first up, let's want to back up and refer to the empirical rule. Please remember plus or minus one standard deviations for all normal curves, not just the standard normal. Plus or minus one standard deviation is always 68%. Or approximately 68%, plus or minus 2 is approximately 95%, and plus or minus 3 is 99.7%. So there's a very, very small percentage outside of 99, outside of the plus or minus 3. All right, we're basically looking at 0.03 or 0.3%. Here, plus or minus 2, outside of that is about 5%. Okay, that's true for all normal curves. However, with the standard normal, when we deal with the standard normal, we're talking about a z-score. All z-scores for the standard normal have a mean equal to 0 and a standard deviation of 1. All right. So whenever someone asks you, hey, what's a z-score? You don't have to know anything to know what the mean is. The z-score for the normal is going to mean is 0. Standard deviation is 1. That's true for all z-scores. Please also remember the empirical rule. But one thing to keep in mind is the empirical rule is based on being centered on 0. It is not a percentile rank. A percentile rank will go to negative infinity to wherever you are. So a percentile rank provides the amount of area or data that is below a certain value. In other words, to the left, a percentile rank for one standard deviation or minus one standard deviation would be the area below minus one standard deviation. So, for instance, what does it mean if you scored at the top 78% of the students taking the SAT test? Well, if I were to draw a picture of that, well, midway would be our mean, and half would be below it. That would be at 0. But what they're saying is 78% scored below you, and that area would be 78%, and would go to negative infinity, even though you can't make a negative percentage. That also means the upper 20, there's 22% that scored above you. Okay. So we're going to use our z-scores and we're going to use a calculator to do this. So they're looking for a z-score of -3. A z-score of -3, well, we know we're going to have 0. And really, I should count out 1, 2, 3, 1, 2, 3, and 1, 2, 3 to -3. And we're looking for this area right here. So let's go to, on the calculator, second vars, norm, CDF, and our lower bound went to negative infinity, so we're going to press the negative raised to the 99th power. Our upper bound is -3, mean is 0, standard deviation of 1, and we get 0.00134. Now, technically, and by the way, we can just cut it off at 4 decimal places, 0.0013. Technically, we could have used the empirical rule. In the empirical rule, we would have gone 1 minus 0.997, but that would give me the area in both tails. And so I'd have to come back and divide by 2, and we'd get approximately the same thing. Not exactly, but approximately. So let's do it real quickly. We'll do it once, and we won't do it again. So 1 minus 0.997 and divide by 2, and we get 0.0015, and we came up with 0.0013. But what's a few thousandths among friends? Because this is tenths, hundredths, thousandths, 10,000ths. We're off by 2 1,000ths, and that's the approximation that comes uh, with the empirical rule. It's close, but it's not as exact as the calculator. Here we're looking for the probability that z is less than -2. So if I'm drawing my picture, all right, and we go 1, 2, 3, well, -2 is right here. So I'm looking for this, and so we're now looking for that percentile rank. So we're going to go second vars, norm, CDF, lower bound, -9 raised to the 99th, upper bound, -3, mean is 0, standard, no, mean upper bound is -2, excuse me, -2. Mean is 0, standard deviation of 1. And the way you're going to show your work on these, and I didn't do it on the last one, is you're going to go norm, CDF, lower bound, negative infinity, -2, 0, 1. lower, upper, mean, standard deviation. Easy work to show. All right, press enter, and we have 0.0227. And once again, we'll just go 4 decimal places. The next one, probability z is less than -1. Mean is 0 because it's a z-score, and they all have mean is 0, standard deviation 1. 1, 2, 3, there's -1. We're looking for this area right here, and remember it goes to negative infinity. So norm CDF, negative infinity to -1, and mean is 0, standard deviation of 1. So let's put some labels on that. Lower, upper, mean, standard deviation. Second var is normal CDF. Still -9, upper bound -1, mean is 0, standard deviation 1. And we get 0.1586. So that means you're about almost at the 16th percentile. All right, you're almost at the 16th percentile. All right, probability of -0. You can't have a -0, so really it's technically the probability of 0. And I should get 50% because that's my mean, so I should be right in the center of the graph. So this should be 50%. Let's run it. And remember, percentile ranks go to negative infinity. So norm CDF, negative infinity, then upper bound of 0. Mean happens to be 0. And our standard deviation is 1. So this is the lower, this is the upper, this is my mean, and this is my standard deviation. And that's supposed to be a positive 1. It's not supposed to be a -1. All right, so here we go. Second vars, normal CDF, lower bound negative infinity. We went up to 0 because that's what they asked for, a z-score of 0. And we end up with 50%, which is what we knew we would get because we've gone halfway. So we're at the 50th percentile. Probability that z is greater than 1. Well, now when I draw my normal CDF or my curve, for 0, 1, 2, 3, and we are above the mean by 1 standard deviation. We are still going to negative infinity, so our work is norm CDF, lower bound, negative infinity, upper bound, we went to +1, mean of 0, standard deviation of 1, lower, upper, mean, standard deviation. Second vars, norm CDF, lower, upper is 1, mean is 0, standard deviation of 1. And we end up with getting 0.8413 as our probability. So you're about at the 84th percentile. Probability is less, z is less than 2. Centered at 0, 1, 2, 3. So here's 2. And norm CDF. I did not give myself enough room, so I'm just going to have to squinch it down a little bit here in a moment. Norm CDF, lower bound, negative infinity, up to +2 for our z-score. Mean is 0, standard deviation of 1. Lower, upper, mean, standard deviation. Second vars, norm CDF, lower, upper, mean, standard deviation. We get 0.977. So about 97% is below it. I'm going to box it over here, 9772. So you're almost at the 98th percentile, not quite, but almost there. And then our last one is z less than 3. And I'm going to try to make room. I hope I have room. I'll draw it with the blue. So 1, 2, 3. Here's our mean at 0. But we want to be at 3. So we're way up here and we're shading down. And this is going to be a norm CDF, still shading to negative infinity. Mean, our upper bound, we stopped at 3 z-scores. Our mean is 0. Our standard deviation is 1. So lower, upper, mean, standard deviation. Second vars, norm CDF. We still have negative infinity. Our upper bound is 3, mean 0, standard deviation 1. And we end up with 99.86%. So 99.8% is below us. So that's our percentile rank, almost 100%. All right. Continuing on. In each case, draw and sketch and find the area under the standard norm curve that lies to the left of the given z-score. Well, this is continuing exactly what we were doing, but instead of working with the empirical rule, we're going to go ahead. You know what? Now let's continue on. We're going to go ahead and say, okay, what if we have something that's not following the empirical rule, and we have negative 1.27? Well, negative 1.27 is below the mean. I'm really not even going to worry about it, but I know it goes to negative infinity. So this is a norm CDF, once again, norm CDF, lower bound, negative infinity, upper bound, negative 1.27, mean is 0, standard deviation of 1. So this is a lower, upper, mean, standard deviation. So second vars, normal CDF, negative 9 raised to the 99th. Our upper bound happens to be negative 1.27, negative 1.27. Mean is 0, standard deviation of 1, because all z-scores have the same mean standard deviation. All z-scores have a mean of 0, standard deviation of 1, and we come up with 0.1020. So about at the 10th percentile, just slightly above the 10th percentile. Here we're at z is 0.43. Well, that means I'm slightly above the mean. So if my mean is here at 0, 0.43 is above it. And once again, we're always shading below when we're working with the percentile ranks. And they're asking for that area. So second vars, norm CD, second vars, norm CDF, lower bounds that. Our upper bound is a positive 0.43, so we should be just over 50%. And sure enough, we're at 66.6. Wow, that's wonderful. So norm CDF, our lower bound, negative infinity, our upper bound, 0.43, mean is 0 because it's a z-score, standard deviation of 1. So lower, upper, mean, standard deviation. And in this case, we got 0.666. So the devil or Damien, I'm not sure which. Okay. All right. In each case, draw a sketch and find the area that lies to the right. So now instead of finding to the left, we're finding to the right. So finding to the right, we're going to go, okay, my lower bound in this case, here's my mean. My lower bound is at negative 1.27, and it's asking us to shade up. Well, what are we shading up to? We're shading up to positive infinity. So this is going to be a norm CDF. My lower bound, negative 1.27. Upper bound is positive infinity. Z-scores all have a mean of 0 and a standard deviation of 1. So lower, upper, mean, standard deviation. Second vars, normal CDF. My lower bound, negative 1.27, because that's where we're shading up. We're shading up to infinity, so 9 raised to the 99th. Mean is 0, standard deviation of 1. and you're about 89% is above you. This is not a percentile rank. This is just saying that 89% is above you, 89.79%. And really, if I subtract it from 1, it's like, oh, you're back at the 10th percentile. All right, you're back at the 10th percentile. So Z is 0.43, and we're looking for the area to the right. So this is going to be less than 50% because I'm shading to the right and I'm above the mean. And 0.43 is about here. And we're shading up, and we're shading up to positive infinity. So this will be a norm CDF. And we're going from 0.43, that's our lower bound, to positive infinity, that's our upper bound. Mean is 0, standard deviation of 1. Lower, upper, mean, standard deviation. Second var's norm CDF. Lower is 0.43, upper is 9 raised to the 99th, mean is 0, standard deviation of 1 because we're working with a z-score. And about 33% is above you, equals 0.3335, or about 66% is below you. All right, so that's that probability. All right, so now they're looking for between two z-scores. Well, between -2 and +2 should be about 95%. Now, remember, the empirical rule is an approximation, so it's not going to be exactly, but they're basically saying, hey, if we go 0, 1, 2, -1, -2, we're looking for this area right here. So this is -2, this is +2. So I'm going to do a norm CDF. Lower bound -2, upper bound +2. It's a z-score, so my mean is 0, my standard deviation is 1. So second var's norm CDF, -2 lower, upper bound of 2, mean is 0, standard deviation of 1. And I end up getting about 95%, which is what we expected. It's a little bit more because it's not perfect. 95, 44. And this is my lower, this is my upper, this is my mean, this is my standard deviation. Don't forget to put your labels. All right. So now we have a 0, -0.1, and z equals 0. So we're looking at a very small interval. Actually, let's make it -1 to 0. Let's not make it the point 0. Let's just assume that's a typo. So let's just go with -1. So if we're centered at 0 and we go to -1, we're looking for this area in this case. So we're looking for a norm CDF, lower bound -1, upper bound 0, mean is 0, standard deviation is 1. This is lower, this is upper, and this is mean, this is 1. Now remember, if it was plus or -1 standard deviations, we'd be at 68%. Well, this is half of that, so we should be close to about half of 68, which is 34. So the second var is norm CDF, lower bound -1, upper bound 0. Oops. And we end up with about 34%, which is about half of 68, which is about what we expected. All right, Z is 0.5 and 1.5. 0, 0.5 is somewhere here. And we're also going to go to 1.5. So we're looking for this area. So this is going to be a norm CDF, lower bound 0.5, upper bound 1.5. Z-scores all have a mean of 0, standard deviation of 1. So lower, upper, mean, standard deviation. Second var's normal CDF. Oops. Lower 0.5, upper 1.501. And we end up with about 24%. So 2.2417 is in that interval from 0.5 to 1.5. All right, this concludes this video. I appreciate you watching. Hope to see you on the next one. Thank you.